Hello students and welcome to another lecture in the C# Fundamental course. This is part of a larger video lecture series that I do at the HTL Leonding, a vocational college for computer science. And if you haven't watched the previous videos or you weren't present in my lectures at the HTL Leonding, please take a look at the previous videos. I will add a link, I think here or here, I don't know, you will find it out. I will put it in the description for you, a link to the videos. Now, what is the topic of today's lesson? The topic of today's lesson are three things: literals, constants, variables, and of course, in conjunction with these three things, data types. This is what we are going to take a look at. You have to really bear with me in this session because we need a little bit of theory before we can put our hands on the keyboard and start typing and start coding. So sit up. I hope you are well rested and I hope you are open for some very interesting theory, and then you can apply all the knowledge in your code. Let's get started. What are literals? What are constants? What are variables? And what have data types to do with them? First, what is a literal? A literal is a simple value. A value that is a number, can be an integer number, can be a floating point number, can be a Boolean value, so either true or false, can be a character, can be a string, and there are even more advanced literals which I'm not going to talk about in more details here. So this is just a value. If you write 42 in your program, we call this a literal. If you write the string hello world in your program somewhere with these double quotes here, then we call this a literal. If you write single quote character, this is a character here, we call it a character literal. I think you got the point, right? Next one. Sometimes we need certain constants over and over and over again. You know that from mathematics. If you have already done some calculations with circles, like the circumference of a circle or the area of a circle, then you know that there is a very important constant, which is called pi. And the same is true in programming languages. Sometimes you have some literals which you need over and over and over in your program. And you don't want to copy them over and over and over again, because maybe they might change over time. Maybe you start a new, maybe you write a game and you have 10 levels. That would be a literal 10. And then you add 2 additional levels. And all across your little game, you have the literal 10. And you have to change it everywhere to 12 because now you have 2 additional levels. You don't want to do that, right? And this is the reason why people invented constants. Constants are symbolic names for literals. So what you do is you write const, then the data type, then the name of the constant, and then the value. This is an assignment. We talked about assignment before. So const int answer equals to 42 is a constant. Answer is the symbolic name for the literal 42. And that works for all different literal data types. Remember the keyword const here. The third thing are variables. Variables are very much like constants, with one important difference: they can change. Variables are also symbolic names, but they are symbolic names for a certain piece of memory. You have heard about memory before. I guess when you bought your computer, it had a certain amount of memory built in, gigabytes, whatever. And in this memory, we can store values, and these values can change. Okay, and we call these memory locations with their names, we call them variables, where whatever this memory is exactly, we'll talk about that later on, but currently it's just a piece of memory with a name where we can store values. And here you see 2 examples. You have a variable called answer, and currently it has the value 42, as you can see here. Or here, this greeting has the value hello world. And over time, when your app executes, the value of these variables can change. That's the difference between constants and variables. Please also note, let me zoom in, please also note the typical writing of constants and variables. While constants are typically written as uppercase, variables are written as lowercase. If you have more complicated names for a constant, for instance, that would be, for instance, the top answer, that would be a longer name, 2 words, a constant name consisting of two words, you use underscores in the middle. That's kind of a convention in C#. You could make it otherwise, so you could also write it in lowercase, but it's really not the usual thing to do. The usual thing to do is writing it like that. And with variables, it looks like this. Top answer. See? So we also used multiple words, and we use uppercase letters at the beginning of each word. This, with the underscores, is sometimes called snake casing, like the animal snake, and this is called camel casing, like the animal camel, because it looks a little bit like a camel when you have this uppercase letters here in the middle. I think you understand what I mean. There is a third writing which we will come across later. I will mention it now. That would be top answer. In C#, this kind of writing an identifier would be used for methods, for instance. If you don't know what a method is yet, no problem. We will discuss that in one of the next lessons. But you can already remember that this is the kind of writing, uppercase and lowercase, that you use for methods in C#. By the way, this we call Pascal casing. Now that has historically something to do with the programming language Pascal, which is very old, and we will not deal with it in this course. In fact, I learned coding with Pascal. Okay, so you now know what a literal is, what a constant is, and what a variable is. And the last thing that we need to talk about is the data type. Every literal, every constant, every variable has a certain data type. The data type defines what you can store in this constant or variable. If you have an int variable, you can only store numbers, integer numbers in this variable. If I have a string variable, it can only contain a string. Same is true for constants. For literals, every literal has a defined type, and you see the different types and writings, the so-called syntax, up here. So with data type, you restrict the values that can be stored in a variable or a constant. Remember that. I know it's a little bit of theory, but we will need it over and over and over again, also today in our examples. Next step. You maybe are now confused, because this is, granted, a lot of theory, so let's take a look at an example to make it much clearer. Here, let's first play around with literals. I will zoom in a little bit so you see it quite nicely. Here you see various literals in conjunction with the console.write function, with the console.write method. Method and function are really, there is a slight difference, but for now, if you hear me saying method or hear me saying function, I mean the same, okay? So console.WriteLine method, and this takes various types of literals. See? In the first line, we have a string literal. In the second line, we have an integer literal. In the fourth line, we have a floating point literal. And in the 8th line, we have a Boolean literal. So take the time and take a look at this program and try to find out what it will do. Did you find it out? It prints, take 3 pizzas and bake it for 1.5 minutes. Then the next line, believe me, it is true that the pizza will be delicious. This is what this program does. It simply writes 2 lines on the screen, but it builds the content of the lines using various types of literals. Good. I think this was pretty clear. I encourage you to now pause the video and do a little typing exercise. Spin up Visual Studio Code just as I showed it to you. Type in this code and use the .NET run command in order to execute it and play a little bit with the code. You will definitely make coding mistakes. You will make typos, typing mistakes. Maybe you will forget the double quotes for a string or something like this. This is super important that you practice these things. Otherwise, you are not going to become a really good coder who can write code in a stable way and fast. So pause the video here, type it in, and come back once your program works. I guess you have done so welcome back. Next example. The next example is about constants. It's very similar to what we did before with the literals, but this time, here we have constants. See, here is a constant. The constant is called school address, and we use this constant because we need the school address in our application 2 times. This is the address of our school, and we do not want to copy it in 2 locations in our app because maybe at one point in time our school could move, and if that happens, we don't want to go through all the lines of code in our app. We simply want to change it in a single place, and this is what the const here is for. You see two constants with two different types here. You have the string constant and you have also an integer constant, so you have two different applications of two different data types. Again, this is now a typing exercise. Pause the video, take my code, type it in a new example, make sure that everything compiles correctly, use the .NET run command, and check whether everything works as expected. Play a little bit with the code, change the constants, maybe introduce a new constant, try to really understand and embrace the code so you can really feel comfortable in understanding what this code does. Next example, variables. Variables look on the first view very similar to constants. Here you see a variable, see it? This variable, it doesn't have the keyword const, so therefore it's a variable, it has the string type. But here we find something new and very interesting and exciting. We learn a new method here, Console.ReadLine. Maybe you can guess from the name what readline does. It reads input from the keyboard. It asks the user, hey, type something in. And when the user presses the enter key, you get the entered line in your app. You might ask yourself what this exclamation mark here at the end is. I'm not going to describe that in detail. We are lacking a certain amount of foundational knowledge to really understand what this exclamation mark is. We will cover that later in this course, or maybe even next year, we will see. For now, just trust me. Add the exclamation mark here, and any warning that C# might give you will go away. So whenever you use Console.ReadLine in this course in the upcoming weeks, add the exclamation mark after the parentheses and everything is good. Let's just call it Harry Potter programming. A little bit of fairy dust and the warning goes away. And it isn't magic, don't worry. I will tell you more about why this isn't magic in at a later point in time. So here you see the variable name. We assign it whatever the user types in. And down here we have another Console.ReadLine statement, and we are using exactly the same variable here. And this is why it has to be a variable, because over time the content of the name changes in our program. Got it? If we would have created a constant name, that wouldn't work. First, this read line, the user can type anything, so it's variable. Wouldn't work. And we cannot reassign the value to a constant. That doesn't work. So, variable. And guess what we do next? Yeah, I think you already guessed it. This is a typing exercise. So pause the video, take my code, type it in, make sure it works, play a little bit around with it, and get back once you did this exercise. Welcome back. I hope you paused the video and you did this exercise successfully. Now, let's talk a little bit about this Console.ReadLine thingy. This Console.ReadLine is just like our good old friend Console.WriteLine, part of .NET, of the platform on which we work. The full name, again, is not just Console.ReadLine, it's System Console.ReadLine. I will not repeat everything I said about adding the system dot. I already did that in a previous video. If you haven't seen it, take a look at it. It's in the playlist of this course. One thing that is interesting, that is maybe not that relevant for now, but it will be relevant in the near future. Readline reads something from the standard input. Now, by default, the standard input is the keyboard, but this can be changed. In the upcoming weeks, I will show you how to change standard input, and by changing standard input, we can also read from files on your disk, for instance. But for now, Console.ReadLine is simply accepting input from the keyboard. There is also a Console.ReadKey, which is very similar to Console.ReadLine. Console.ReadKey will simply wait until the user presses any key. It will return the key, which we will not deal with now, but we will do that later on. For now, Console.ReadKey is a way of pausing your program until the user presses a key. That is what you can do with that one. Again, this is not just Console.ReadKey, but System Console.ReadKey. I think you got the point so far. In the upcoming, with the next methods and next classes, I will not always say that you can add system dot in front. You simply know that by now, okay? I will not describe that again. I think this is a concept that you should have understood so far. Let's talk a little bit more about data types. C# has a lot of data types, and if you want to know all the data types, follow this link here. I will not do it now. You can do it whenever you work on your own exercises. String is a string, character, Boolean, true or false. Then we have some integral numeric values, no decimal places, so 42 for instance, and we have some floating point numeric values, 1.5. Now, this is a floating point value. As you can see, for the integral numeric types and the floating point numeric values, we have a lot of different data types. And if we take a look at the documentation, then you will see a list of all the integer types that C# has. And they differ in the value range that they can store. You see the value range here. It doesn't make sense that I read it for you. You can read it yourself. And whenever you write a program, you have to think about which type should I use in order to store the values in this variable. For instance, if you would like to store the age of a person, probably byte would be a good option because we don't have negative ages. And 255, I am not aware that any person on this earth has lived longer than 255 years, so that would be pretty okay. Yeah? If you want to store the number of minutes in a day, for instance, then probably byte would not be sufficient. You can come up with your own suggestion of a data type. But keep in mind that all these variables also differ in the size that they need in memory. As you know, your computer has a limited amount of memory, and we don't want to waste this memory. So choose a data type that is large enough, but don't choose a data type that is hugely too large. If you simply want to store the age of a person, it doesn't make sense to use a long value because, hey, I don't think that this is relevant as the age of a person on this earth. Maybe in another universe, but not in our earth. If you want to store the age in milliseconds or something, maybe that is a different story, but for now, choose the proper data type. As small as meaningful, but don't choose a data type that is too large. The go-to data type, the data type that is mostly used, is integer. This one here. It's a 4-byte integer. If you don't know what a byte is, don't worry. You have other courses where you discuss bits and bytes and things like that in more details. For now, the higher the number, 32-bit. Every byte has 8 bits, so this is a 4-byte integer. The higher the number, the more memory it takes. Okay, very good. By the way, the same is true for floating point values. If we take a look at floating point values, we have 3 different types of floating point values, and again, they have a different size and they have a different value range. For now, for this course, mostly float and double are relevant, depending on the precision that you need and the size in memory that you are willing to accept for a certain value, okay? So float and double, please remember that. Good, that was data types. If you want to write a literal for a certain data type, so just a value, you have to remember some syntax constructs. I'm very sorry, this is one thing that you really have to remember. You can always look it up here in my slide deck. Strings, double quotes, characters, single quotes, Boolean, lowercase true or false, integer, just a value, long with an uppercase L at the end, float with an uppercase F at the end, double with an uppercase D at the end, and decimal with an uppercase M. You can remember that M like money with an lowercase m at the end. Did I say uppercase F? No, lowercase f, lowercase d. I don't know what I said, but you can read it on your own. So these are literals for certain data types. So if you want to define a double value, you have to specify 42D. Then you get a double value. One more thing that we need in order to get started with some examples, and that is string parsing. What is string parsing? Sounds very fancy. It is fancy, in fact, and it's super useful. You will do it over and over and over again in your career as a developer. So, string parsing is the process of turning a string into another data type. What does that mean? Imagine that you ask the user to enter a number, but the user only has a keyboard, and what you get from the keyboard is not a number from a programming perspective, but you get a string. You get, let me type that in here, you get, for instance, 42 as a string, not as a value, as an integer value. If you want to calculate with this number, you have to turn this string into an integer value, or a double or a float value, or whatever you want. And this process of turning the string into a numeric value or into a different data type's value is called parsing. Of course, a lot of things can go wrong with parsing. If I enter hello world and you would like to turn that into an integer, your program will crash. There are ways to handle such crashes. We'll not deal with that yet, but for now it will simply crash and we accept that, okay? This is how you do it. You have the string that can be a literal, that can be a constant, or that can be a variable. Then you use the target data type in which you would like to turn this, and you use the method parse. There are other methods which allow you to very detailed specify how to parse this stuff, but again, this is stuff for later. For now, int.parse or double.parse or float.parse, all these methods simply work. You give them the string and they will give you a return the data type that you have chosen, in this case, integer. So this .parse thing is also something that you should definitely remember. Okay, once we have the variables or constants in the correct data type, we can apply some operators to them. Operators would be, for instance, arithmetic operators. Here are some important ones, the rest can be read in the documentation. These are basic algorithmic operators: adding, subtracting, division, multiplication. 4 basic algorithmic operations. The next line, incrementations, these one, consist of plus plus, plus equals, minus minus, minus equals. I will show you an example on the next slide so you will definitely understand them. And the last thing, remainder, it's also a very important one. Maybe you can't remember from mathematics what a remainder is. Let me quickly refresh your memory. If you, for instance, have 5 and you divide it by 2, what is the result? Yes, 2, because 2 times 2 is 4 with a remainder of 1, right? If we have 10 and we divide it by 6, the result is 1 with a remainder of 4. Got it? And this operator here, this percentage operator, which is called the modulo operator, will always return this here, just the remainder. It will not return the result, it will just return the remainder. That means if I say 10 percentage 6, I will get 4, because 4 is the remainder of dividing 10 by 6. You might ask yourself, why do we need that? Why do we need the remainder? Haha, believe me, there are a lot of applications for this modulo function. You will use it nearly on a daily basis when you write code, and I will show you a lot of examples later on. I think the second or third example today will already have to do with the modulo operator. Next one, comparison operators. They are simpler. See, you can compare here. You can compare values, greater, lower, greater than, lower than. You can check whether 2 values are equal, but if you want to check whether something is equal, you have to add double equal sign. So we have a clear distinction between the assignment of a value. Can remember, int x equals 42. That is an assignment, but that is different from checking whether x is a certain value, and that would be the double equal sign. And exclamation mark equal, the exclamation mark here means not. Whenever you see an exclamation mark in some kind of checking comparison, it means not. Okay? Not equal. Remember that. Okay. Not all operators make sense, obviously. If we use plus for two integer values, 10 plus 20 equals 30, works. But we cannot use divide for string values. Hello divided by world. Makes no sense. Or Boolean values. True, greater, false. No, that isn't the thing. So it doesn't make sense. Remember that. Don't worry. If you do something wrong, C# will tell you. C# will give you an error and will tell you that a certain operator is not defined on certain data types. Keep that in mind. I told you that I want to show you a little bit about the incrementation operators. And if I zoom in a little bit, you see the increment operators here. I think I don't need to read them for you. Let's quickly go through it. We start with a variable I, which has the value 1, as you can see here. So this is, what do I do wrong? So here, we start with the value 1. Then we add 1, of course, plus. We subtract 1, of course, minus. We assign the result again to I. We are changing I. Then we have the plus plus operator. It's the same as line 3. Plus plus simply says I equals I plus 1. That is what plus plus does. To be honest, there is more magic behind plus plus, and there are really a lot of nifty details to consider when using plus plus. But for now, just use it like that, and it will perfectly work fine. Minus minus is the same in the other direction, so it reduces the value of I by 1. It decrements. We say decrement I by 1. And if you want to increment or decrement by values other than 1, you use the plus equals and the minus equals operator here. Pretty obvious, right? Not that difficult. So avoid line 3 and 4. Use plus plus, minus minus, or if you want to increment and decrement by larger values, then use plus equals or minus equals. Super useful. Okay, math. C# has a bunch of interesting math functions built in. These math functions contain a lot of very useful mathematical functions and constants. For instance, pi, absolute value, trigonometric functions like sinus, tangents, cosinus, and things like that. The next slide contains a table with the most important mathematical functions that you will need in this course. Whenever you need them, you can go back to this slide and then look it up. Look it up in the documentation, take a look at some examples, things like that. Just like console, the full name of math is system.math. We already talked about that. Okay, here you see the most important functions that we need in this course. Pi. Obviously, if you want to calculate something with a circle, we need pi, and math.pi gives you the value of the constant pi. Absolute value means that if you say math.abs from 5, you will get 5. But if you say math.abs from -5, you also get 5. That's the absolute value. Floor and ceiling are two interesting ones. Floor, like the floor of your room, and ceiling, like the ceiling of your room. What they do is they give you the largest integral value or smallest integral value lower than or greater than the specified number. Sounds complicated? It isn't. Floor means you always go down to the floor. 1.4, go down to 1. 1.9, go down to 1. 2.1, go down to 2. Ceiling, other way around. 1.4, go up to 2. 1.9, go up to 2. 2.1, go up to 3. I think you got the idea. Floor and ceiling. Min and max are also nice. Let me give you a quick example. If you, for instance, say math.min of 1 and 2, the result will be 1, because 1 is the lower of these two values. If you say math.max of 1 and 2, you will get 2, because 2 is the greater of the two values. That's all these two methods do. You think that this is not useful? Oh, it is. Believe me, you are going to use this in this course, in this chapter, in an example a little bit later. Now, power is the mathematical function something to the power of something else. Okay? So, for instance, if we have 10 to the power of 3, that is 10 times 10 times 10, because 10 to the power of 3. 10 times 10 times 10. Okay? 2 to the power of 4 is 2 times 2 times 2 times 2. Okay? That is the power operator. So what you essentially do is you say, for instance, here, math.pow 10, 3, and that is equal to 10 to the power of 3. Sometimes you write it like that, and it's 10 times 10 times 10. Got it? That is pow. Yeah, and round is pretty obvious. You can do rounding. It rounds the value to the nearest integer. 1.4 becomes 1, 1.6 becomes 2. Please take a look at the documentation. You can follow the link here if you want to know all the details about what you can do with rounding. It is not that important for the upcoming hours and exercises. The other ones are much more interesting. Very well. You did it. You did it. You followed me through the entire theory of today's lesson. So now we can dive right into the code. And I decided today that we split this video a little bit. I will now show you the exercises that you have to do on your own. And then we'll do a break, because afterwards we will add another little bit of theory, but I will dedicate a different video, a part 2 of this lesson with the additional theory. But first, you have to practice what you already learned. The first example is again a typing example. This example implements an area calculator. Let me walk you through this example so you really understand it. In this case, I want to calculate the area of a room. The room is defined by the length and the width of the room. See it? So what we do is we use a little bit of coloring on the console. We did that in the previous lesson. We do something with WriteLine. Can you remember the magic of \n? If you can't, rewatch the video or take a look at my slides. And then we apply the knowledge that we learned today. We define a variable and use the parse function to turn an input of the user into an integer value. Okay? I showed you that a minute ago. Then we do the same for the width, and here we have the so-called business logic. This is the logic for calculating the area of the room. This is the line with the area of the room. And then we simply print the area of the room, and here we also apply knowledge that we gathered today. We use an operator, plus, but in this case not for numbers, but for texts, for strings. We take a string here, this one, and we add another value. And guess what C# will do? It will turn this numeric value into another string and concatenate them. So the output will be the area of the room is something. Then we wait for the user to press a key, Console.ReadKey. And once the user pressed the key, we clear this, we cleared the screen and set the color back to the original values. Oh, not back to the original values, could be different before, but we set it to black and white. So, what is your job now? Sit down, pause this video, and type in this code. Type in this code, try to really understand it, make mistakes and try to fix them. Compare it to what I have here. This is again a typing exercise. An exercise for you to master some syntax problems. Okay, please do not copy the code. Do not copy the code. Type it in and make mistakes, and ask me if you are in my lecture, ask another teacher if you are in a different class, ask some adults or maybe an older sister or brother or whoever you have in your surroundings if you have some severe problems. Okay. A quick note, by the way, this, what you see here on the right hand side, is exactly the algorithm that you just saw, but it is in the form of a flowchart, because sometimes you need a graphical representation of what you are doing. Maybe you want to describe what's going on in your application to somebody who is not capable of reading code. Some people, when they see something like that, they immediately turn away and say, oh my god, that's way too complicated, I can't understand that. But then you can present the same algorithm with these nice little boxes. You see, this is a statement or an operation described in text. This is an operation. This is an output. You see the different shapes here. This is an input. You see the different shapes here. This is a calculation again. So this is a nice way of graphically visualizing the algorithm. This has been done for quite a while. We call this a flowchart, and I will show you more algorithms with flowchart over the course of this lecture. Okay? Good. Next example. Did you successfully complete the last one? Here I have another one. This is a number analyzer. Let me walk you through this example before you type it in. Here we again use the Console.ReadLine with the parsing. We had that before. But then we do something interesting. We use the modulo operator. We say number modulo 2, and then we compare the result, see it here, with 0. And that will give us a Boolean variable. And then we use this Boolean variable to say either it is true that the number is even, or it is false that the number is even, depending on whether the user entered an even or odd number. Do you understand the difference? Let me quickly show you that. If the user enters 3, 3 modulo 2 is 1, because 3 divided by 2 is 1 with a remainder of 1. So this is 1. So 1 indicates an odd number. If we say 4 modulo 2, we have 0. That has to be an even number, because 4 divided by 2 is 2 with no remainder. So the modulo function can be used to find out whether a number is even or odd. Okay? And then we also use the a comparison operator here, number greater than 5. That will also give us a Boolean value. So we have a Boolean variable here. And we again say it is true or false that the number is greater than 5. At the end, the number analyzer adds 1 to the number and prints the next number on the screen. So this second sample is all about operators that you might not have seen before starting coding. Again, pause the video, type in the code, play with the code, fix all potential mistakes, run the application with .NET Run, and see whether everything works. And the final example for this video before we do a break here is the area calculator for circles. Now, for this example, I don't present the solution. So this is your first job to write your own code and come up with your own solution. Remember the area calculator that we did for the room with the width and the length? You have to now write a program that does exactly the same thing, but this time for circles. So this time you have to ask the user for the radius of the circle, and then you have to calculate the area of the circle given this formula here. The area of a circle is pi multiplied by radius to the power of 2. Radius times radius. A equals pi times radius. This is how you calculate the area of a circle. If you are not sure what I mean with pi and radius to the power of 2, ask your mathematics teacher. They can repeat how to calculate an area for a circle. And at the end, you print the area of the circle on the screen. So I suggest go back to the sample with the area of the room, copy it, Control C for copy, Control V for paste, and then change it so that the whole program now works for a circle and not for a rectangle. This is your, let's say, homework. So sit down and try to solve this challenge. If you solve this challenge, you have done a huge step towards becoming a really good coder. We have not completed this lecture about literals, constants, variables, and data types yet. We still have a little bit to go, but I think for now the video and the lecture is long enough. You have some homeworks, you have some exercises. Please do them, because remember, mastery comes with practice. So keep on coding, keep on practicing. I see you next time. Looking forward to that. Bye for today.